All right, welcome back. So the previous video, I tried to show you how angles are measured, right? We measure them in degrees, and how if you start at 0, you eventually go all the way around, and you'll end up with a complete circle. You'll have 360 degrees. So every circle will have exactly 360 degrees. But oftentimes you'll be presented with problems or questions where you have to divide those circles into equal parts, and you have to find the exact measurement for each of those parts, which is fine because the one thing you always can count on is that every circle has 360 degrees. So we just have to figure out how many equal parts that each circle has. So the first one here, you can tell there's 4 parts, right? Got 1, 2, 3, and 4, right? There's 4 equal parts. So if you have a circle with 360 degrees, and there's 4 equal parts, you're basically just doing division or multiplication, right? You're multiplying to solve this division problem. So you figure out what's 360 degrees divided into 4 equal parts. Well, I know that 4 times 9 is 36. So when I subtract 36, I get 0. Bring down my 0. Well, 4 times 0 equals 0, so that's 0. So that means that every single part here is exactly 90 degrees. So this is 90, this is 90, this is 90, and this is 90. And also hopefully you saw that to begin with, because if you notice, the lines that are dividing this circle are perpendicular right here, right? These lines intersect with each other at a special angle that we call perpendicular. So anytime you see that, let me write that word out. If you have perpendicular angles or perpendicular lines, right there, you know that it has to equal 90 degrees. And then some other things, if you take this 90 degrees plus this 90 degrees, if you make half a circle, that's 180. So you have 180 up here and 180 down here. And now if you add those together, that's 360. Let's take a look at another one. This one's divided into 5 equal parts. So let's do the division, right? We have 5 parts. 1, 2, 3, 4, 5. So what is 360 divided by 5? Well, one thing we don't have any perpendicular angles, but these are all acute angles. So all of these angles are going to be less than 90. They're going to be greater than 0, but less than 90 because they're acute. At least I believe they are. Let's see, 5 times 7 is 35, so I'll subtract 35. Bring down the 1, and then the 0. 5 times 2 is 10. So each of these, every single one of these pieces is going to be 72 degrees. So if you were to measure the angle for all 5 parts, it would be 72. We're talking about this right here. So if you measure from here to here or from here to here, right? And you can see when you connect those, that creates a circle again. So every single part here is 72 degrees because there's 5 equal parts and there's 360 degrees in a circle. Now this one has 6 equal parts. You can see 1, 2, 3, 4, 5, 6. And it's the same process over and over. Well, 6 parts. Again, a circle 360 degrees. 6 times 6 is exactly 36. A remainder of 0. Bring down the 0. Well, 6 times 0 is 0. That means every single piece here has to measure 60 degrees. And if you notice, 60 degrees is an acute angle, right? Because it's less than 90. So the only one that was a special angle in that sense was the first one. This was exactly 90. That's the right angle. All these others are acute angles because they're less than 90. So here, this one's less than 90. So there's some more. Let me grab this one. There's another one. Oops. Sorry. Meant to grab it and bring it over for you right here. Let's see, this one is divided into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. Let's see what happens. So we have 8 equal parts and we have a 360 degree circle. 8 goes into 36 4 times. I'll take away 32. That's 4 left over. Bring down to 0. 8 goes into 40 exactly 5 times. 40 take away 40 is nothing. So every single piece in this circle, again, it's acute. They're all acute, and they're all exactly 45 degrees. So what you're saying is you can take all of these slices or parts of the circle, and you can add them together, and you'll get right back to 360 degrees. So this one I divided into 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my 360. 9 times 4 is 36. I'll take away 36. Bring down my 0. 9 times 0 is 0. So all of these are 40 degrees. So you can see the more even part, or the more equal parts you divide a circle into, then the smaller the angle becomes for each part, or the smaller the measurement becomes for each one, right? Like we started with 90. Remember over here, 4 equal parts, it was 90 degrees. When you got 5 equal parts, it went down to 72 degrees. 6 equal parts, it's at 60 degrees. Let's see here. Then we went to 8 equal parts, we're at 45. 9 equal parts, we're down to 40 degrees. Well, here we are with 10 equal parts. So the measurement, the angle measure is going to get even smaller. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So see 360 divided by 10. 10 goes into 36. What is that? 3 times? Minus 30. 10 times 3 is 30 with a remainder of 60. 10 goes in there 6 times. Right? So each of these parts, again, it got a little bit smaller, but each of them is going to be exactly 36 degrees. Because it's 360 degrees total divided into 10 equal parts. And I just have a couple more, I think. Actually just one more. So the last one, it's kind of like if you were to, if you remember learning how to tell time on a clock, right? A clock will show you 12 hours, right? From 12. If this was the 12 o'clock hour, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's cut into 12 equal hours of 12 equal parts. And so for a 360 degree circle that has 12 equal parts, well, 12 times 3 is 36. Subtract, bring down the remainder. Well, 12 can't go into 0, it goes in there 0 times. So every single one of these pieces is 30 degrees. So you go 30, 30, 30. It just goes 30 all the way around. And I'll do my best to kind of show you what I meant by a clock. And then I'll stop the video. I know I've been rambling too long. But if this is the 12 o'clock hour and this is the 1 o'clock hour, this would be 2, this would be 3, 4, 5, 6, 7, 8. This is your 9 o'clock hour, 10, 11, and 12. So the distance in degrees between every hour is 30 degrees. So from 12 to 1, that's 30 degrees. And then from 1 to 2 is 30, and from 2 to 3 is 30, and from 3 to 4, that's all 30 degrees every time around. So if you measure, again, you just create a circle within a circle. From here to here, from here to here, all the way around. You can see every time you go from one hour to the other, and you finally connect it back at the end. And I didn't do a good job with that, maybe. Right? You're basically just creating a circle. So every time you take the measurement in between, it goes 30, 30, 30, 30, all the way around. Okay, so if you have any questions about how to find the measurement, like for parts of circles or equal parts of circles, just let us know.